Thank you. And today we're talking about the average value of a function. So as you can see, the average value of n numbers, suppose they are y1, y2 to yn, then the average value, it will be the sum of these values divided by the numbers of the values, which is n in this case. That is for discrete value. And suppose that these value y follow a graph f of x, for example, or t, temperature of time, which is a continuous function, is in the green, the blue lines here, then the average of this will be the purple one here. The similar idea to the Riemann sum, we subdivide the domain from 0 to t, or in general, we consider the function y is equal to f of x, where x from a to b, right? Then delta x is the distance in each intervals, which is b minus a over n. Then the average of the function will be of the points from xi star to xn star will be the sum of f of xi star up to xn star divided by the number of points. So suppose the temperature is discretized into 24 rectangles. Then n will be 24. And from these relation, delta x, we can review in the section 6.1 or previous sections. You can do it. Delta x is b minus a over n. Therefore, we can find n from this formula, which is the quotient b minus a divided by delta x. Delta x is given because then we can compute n here. So replace n by b minus a over delta x and do some algebra. We get that, okay, the average will be this, b1 over b minus a multiplied with a sum from I is equal to 1 to n of fi. I think it should be f of xi star. This is a sigma notation. There's a typo here. So if we discretize the domain finer and finer, when n approaches infinity, then the limit here becomes 1 over b minus a integral from a to b, fx dx, which is exactly the definition of the Riemann sum. So therefore, we have the average value of f on the interval from a to b is this guy. That is a formula for this average function. Now let us compute an example, okay? So let us consider this example, example 1 here, which is the function f of x is defined as 1 plus x squared on the interval from -1 to 2. So according to the formula above here, right, let us write it slowly. This is the question. And what we know here is the average value function. which is this guy. So we are asked to find the average value function. And this is the average value function formula. So in this case, what is A and what is B?
A is -1 and B is 2.
Thank you. Perfect. That is what we are given, right? And we want to compute the average value of f. Then from this formula, we have that f average will be 1 divided by b minus a, which is 2 minus a is -1 here. And this is integral from a to b, which is -1 to 2. And the function f of x dx here, which is 1 plus x squared dx, right? So that is what we have. And now our job is to compute this integral, right? So first, what is the numbers here, the fraction?
1/3.
Perfect, 1/3. Integral from -1 to 2 of this guy. So we can do it directly, right? Or now we use integral properties. We can separate it into two integrals. Yeah, just a reminder, you don't have to do it in much details. But now what we can do is to find the integration here. So what is it? We need to find the antiderivative of 1 and antiderivative of x squared, right? Thank you, Lexi. Antiderivative of x is, of 1 is x. Very good. Antiderivative of x squared is, so let us do it slowly. It is x squared plus 1, right? Divided by the power of this, which is 3, which is 2 plus 1. That is how we compute the antiderivative of this guy. And x will run from the lower limit, which is -1, to the upper limit, which is 2. Remember, the antiderivative of a sum is the sum of antiderivative. But if you see x antiderivative of x times x, can we write it as x squared divided by 2 times x squared divided by 2? Because x squared divided by 2 is antiderivative of x. X squared divided by 2 is antiderivative of x. Can we write it this way? Any idea? Is there anything wrong here? Here, this is a product. we cannot find the antiderivative of a product this way. We can only do it if it is a sum or a difference. Be careful, because I saw some of you did this in the test, which is not correct. So be careful. So this is not correct. Just a reminder. Let me leave it here, down here. But now let us continue here. This guy, okay? Oops. Let us simplify it first. This is 1/3 x plus 1/3 x cubed from x is equal to -1 to x is equal to 2, right? So the first value will be, what is it?
2 plus 1/3, 2 cubed.
Perfect. But remember, there's a 1/3 in front of that, right? 2 plus 1/3 of x cubed. Oh, x, which is 2. We substitute the value of the upper limit, right, to the function here. And then we subtract the evaluation of the lower limit, which is -1 here. And what is it next? What should we put it here?
-1 cubed.
Very good. -1 to the cube, which gives us -1, right? So we can simplify it. So this becomes 1/3 of 2 plus, here is 8/3, right? And this guy is -1/3, -1, and here is becomes -1/3. So this is a whole number. This is a fraction. So we can sum them up if they have the same denominator. So that is why we need to multiply by the common denominator, which is 3, and then divide it by the same things, which does not change the value of the final result. But now they have the same denominator. So it becomes 1/3 multiplied here 2 times 3, which is 6 plus 8, then divided by 3, minus 1/3. And here it would be -3, -1/3, right? And what do we have finally? What is it here?
(14/3).
Very good. And here?
We're going to have -1/3 times -4/3.
Perfect. Then here, negative of it times negative here, right? Which gives us a positive. So this guy is 14/9. Negative times negative gives us a positive things here. 4/9, right? And finally, it will be 18/9, right? And we need to simplify it. 18 is 9 times 2, 9 cancel with 9 give us 2. So the answer for this is the average function of this original function. The average value is 2 here. Okay. Is it clear? Do you have any question about this? If not, then let us continue. Okay. So, and in to be continued, this is the mean value theorem for integrals. Suppose f is a continuous function on a and b. Then there is a number c in a and b such that f of c is exactly the average value, which is 1/b minus a times integral of from a to b of the function f(x) dx. So if we want to get rid of the number 1/b minus a here, in the right-hand side, what should we do?
Multiply both sides by b minus a.
Thank you. Is it Daniel? So when we multiplied both sides by the same number b minus a, then in the right-hand side, they will cancel each other here. And finally, it gives us this formula. So this is the mean value theorem for integrals. Okay. Geometry, you can imagine this. Okay, this is the function f on the interval from a to b, then the average value of this is the purple line here. And the mean value theorem tells us that, okay, f is a continuous function, then there is a point here on the line f of x, which is also the point on the, we'll cut the average value here at the point C in A and B. That's it. Okay. Now we can, in the previous example, the function f of x is 1 plus x squared on the interval from -1 to 2 here, right? We found that the average value is 1/2, 3 integral from -1 to 2 of fx dx, which is 2, right? And prove that use the mean value theorem. For integrals to show that there is a number c in -1 to 2 such that f of c is f average here. Okay, this is the second example. So from the previous example, we know that f average is 2. The function f of x is continuous on the real lines, right? Which is from -infinity to infinity. Therefore, it is continuous on the interval from -1 to 2. Okay. Then, okay, here, this is the mean value theorem. If f is continuous, then they confirm that there is a number c in this interval such that here. So it's satisfying the condition of the mean value theorem. Therefore, we conclude that such that f of c is f average, or 1 over 2 minus 3, 1, which is 1/3, integral from -1 to 2 fx dx, which is 2 from the previous example, right? Or f of c times b minus a is integral from a to b fx dx, right? The same thing. So what is f of c?
2.
Yes, from this, we know that f of c is 2. Very good. That is one thing. Anything else from the formula? Here, this is the formulation of f of x, right? If the input now is c, then f of c will be
1 plus c squared.
perfect. From these two equations, we conclude that 1 plus c squared should be 2, right? Now our job is to find the number C. Okay, how can we do that? This is a quadratic function, right? So what should we do now?
Isolate C.
Perfect. So if we isolate C, and how can we do that?
Subtract 1.
Perfect. Which is C squared will be 1 here, right? So, which means C will be
Square root of 1.
square root of 1. What else? Remember.
Plus or minus.
Yes, plus and minus. Be careful. There are two solutions. Plus 1 or minus 1. Okay? Or we can do it this way. From C squared equal to 1 here, right? Then let us write a quadratic function using a formula. C squared minus 1 is equal to 0. 1 is 1 squared. They are the same thing, right? So a squared minus b squared, and we know that this is exactly as c minus 1 and c plus 1, right? Do you remember the formula now? A squared minus b squared is a minus b times a plus b. And from this, the product of two things is equal to 0, then each of them will be 0. Or in other words, C should be 1, or C is negative 1. Anyway, finally, we found two numbers, 1 and negative 1. And we see that 1 belongs to the intervals. From negative 1 to 2. And negative 1 also belongs to the interval from negative 1 to 2. So we accept both solutions. Is it okay? Is it clear for all of you?
Yes.
Thank you. But now let us visualize it. This is a coordinate, Cartesian coordinate. And as you remember, the x squared the graph x squared, y is equal to x squared. At 0, it will be 0. At 1 or negative 1, the graph will be 1. At 2, it will be 4, right? Therefore, the graph of this guy will be like this. Our function, x squared plus 1 here, x squared plus 1. It means that the graph here will be shifted up 1 unit, right? So it means that the graph here will be shifted up like this one. Go up here, and up here. It will be somehow like this. This is the function y is equal to 1 plus x squared, right? And the average function is 2, right? Which is this guy. So as you can see, from the interval from -1, which is this guy, to 2 here, the average function of the function y is 1 plus x squared would be the purple area here. And the average function will have 2 intersections. One is here at 1, and the other here is at -1. This is how we can see it in the graph. Okay. So the second example is clear, right? Do you have any question about this? Thank you. It's clear. So then let us do another example. So this average function is not difficult. So this is just a new idea. So now show that the average velocity of a car over a time interval t1 and t2 is the same as the average of its velocity during the trip. So, reminder, if the displacement of the car is a the equation of S of t, right? From T1 to T2. Then what is the velocity? Do you remember? The velocity will be the derivative with respect to t of the displacement function, or it is S prime of t. Okay. And the average velocity is given by this relation. V average velocity will be the ratio of delta S over delta T, right? And delta T in this case will be the time from T2 minus T1, right? Delta S is the change in time of the displacement, which is S of T2 minus S T1 here. Okay. So these are all the relation we know. We need to show that the average velocity is the same as the average of the car, the average velocity of the car over a time interval here. This is what we need to show. It's also the same as the average velocity. And this is the average velocity, right? In other words, we need to prove that V average is 1 over T2 minus T1 integral from T1 to T2 of the velocity function with respect to time, right? In other words, we need to prove this guy. Okay. This is what we need to prove. Is it clear what we need to do? Do you have any question about this?
No.
Okay, then we are clear what we need to do, right? So now let's prove it. we have that according to the mean value theorem, the average velocity is 1 over t1 minus t2 from t1 to t2 of vt here, right? And let us replace vt by this relation. Okay? Which is 1 over t2, this is t1, minus t1 integral from t1 to t2 of s prime dt, right? Oh, interesting, right? Integral of the derivative of s, then what do we have here? What is the integral of s prime?
S.
Perfect, which is s of t, right? And t running from t1 to t2. So from this, what do we have? We need to evaluate the value at the upper limit, right? Which is 1 over t2 minus t1 times s t2. Okay? Subtract the evaluation of s as the lower limit of t1. Okay? So what is the common things about these two fractions, these two products? This guy is a common factor, right? Can we factor it out? If we factor it out, what do we have on the right hand? The parentheses here?
S of T2 minus S of T1.
Perfect. That's it. Or we can write it as S of T2 minus S of T1, which is exactly the formula of average velocity, right? Then we're done. Okay?